Hi guys, welcome to my channel. I am from SVC Bangalore. My name is G. Srinath from the Department of Computer Science, Data Science, subject Principles of Programming. Topics are structures of C program, quadratic equation, while loop and do while, formatted input and output statements, T differences of functions and pointers. Coming to the structure of program. Introduction to C programming. C is a high-level programming language developed in the early 1970s. It is widely used for system programming and application development. Understanding its structure is essential for writing effective code. Basic structures of C program. A C program typically consists of a series of functions. The main function serves as an entry point for the execution. Other functions may be defined to perform specific tasks. Preprocessor directives. Preprocessor directives are commands that give instructions to the compiler. They begin with a hashtag symbol such as hashtag include and hashtag define. These directives are processed before compilation of the code begins. Header files. Header files contain declarations of functions and macros. The standard library header file is included using hashtag include studio.h. Including header files allows access to built-in functions and types. The main function. The main function is a program where execution starts. It is defined using the syntax int main brackets open and close flower bracket and slash code. Variable declaration. Variable must be declared before they are used in a program. The declaration specifies the type of variable such as int or float. Proper variable declaration is crucial for memory management. Data types. C supports various data types including int, float, char and double. Each data type has a specific size and range of values. Choosing the correct data type is important for efficient data management. Operators in C. Operators are symbols that perform operations on variables and values. Common operators include arithmetic, relational and logic operators. Understanding operators is vital for performing calculations and comparison. Control structures. Control structures determine the flow of execution in a program. They include conditional statements like if else, and switch. Looping structures like for loop and do while loop repeat code execution. Functions. Functions are reusable blocks of code that perform specific tasks. They can take parameters and return values to the calling code. Defining functions enhances code modularity and readability. Arrays. Arrays are collections of variables of the same type stored in contiguous memory. They allow for efficient data handling and manipulations. Proper indexing is essential for accessing array elements correctly. Pointers. Pointers are variables that store memory addresses of the other variables. They are powerful tools for dynamic memory management and arrays. Understanding pointers is crucial for advanced C programming techniques. Input and output. Input and output operations are performed using standard functions. Functions like scanf and printf handle user input and output display. Proper handling of input or output is important for user interaction in programs. Comments in C. Comments are used to explain the code and make it more understandable. They are ignored by the compiler and do not affect program execution. Using components effectively can improve code maintainability. Conclusion. Understanding the structure of a C program is foundational for programming. Familiarity with its components leads to better coding practices. Continuous practice and exploration of advanced features will enhance skills. Now coming to the second part, quadratic equation in C programming. Introduction to quadratic equations. Quadratic equations are polynomial equations of degree 2. They are typically expressed in the standard form of ax square plus bx plus c equals to 0. The solutions to these equations are known as roots and can be real or complex numbers. Coming to the components of a quadratic equation consists of three coefficients a, b and c. The coefficient a cannot be 0, otherwise the equation becomes linear. The values of these coefficients determine the nature of the roots. Nature of roots. The nature of roots can be determined using the discriminant formula d equals to b square minus 4ac. If d is greater than 0, there are two distinct real roots. If d is equals to 0, there is no real root, a repeated root, and d is less than 0, the roots are complex. C program structure. A C program to solve a quadratic equation consists of header files, main function and the logic. The standard input or output library is typically included for user interaction. Proper variable declarations for coefficient and roots are essential for the program. Input coefficients. User input is crucial for determining the coefficients A, B and C. The program prompts the user to enter these three values at runtime. Input validation can be implemented to ensure proper numeric entries. Calculating discriminant. The discriminant is calculated using the formula d equals to b square minus 4ac. This value will help the determining the nature of the roots. The calculation must be performed with care to avoid integer overflow. Finding roots. Roots are calculated based on the value of discriminant. For d is greater than 0, the roots are calculated using the quadratic equation bracket minus b plus or minus root of d divided by 2a. For d equals to 0, the root is calculated as minus b divided by 2a. Handling complex roots. If the discriminant is negative, complex roots are calculated. The roots can be expressed in the form minus b divided by 2a plus or minus root d divided by 2a. The imaginary unit I represents the square root of minus 1. Complete C program example. A complete C program includes all previously discussed components. The program must compile successfully and run without errors. Proper formatting and comments make the code more readable and maintainability. Compiling of C program. The C code can be compiled using a compiler like GCC. The comment GCC 0 quadratic.c is commonly used. Successful compilation results in an executable file that can be run. Running the program. The executable can be in a command line interference. The user will be prompted to enter the coefficients of the quadratic equation. The problem will then display the roots based on the calculations. Error handling. Error handling is crucial in ensuring the program runs smoothly. Check for division by 0 when a equals to 0 and prompt the user accordingly. Implement checks for invalid input types to avoid runtime errors. Testing the program. Testing ensures the program works for various scenarios. Test cases should include distinct real root, repeated roots, and complex roots. Documenting test results helps in debugging and validation. Applications of quadratic equation. Quadratic equations are widely used in physics, engineering, and finance. They model various real-world phenomena such as projectile motion. Understanding their solutions can aid in optimization problems. Conclusion. A C program for solving quadratic equations combine mathematical concepts with programming. Mystery of such program enhances problem solving skills in computer science. Quadratic equations serve as a fundamental topic in both mathematics and programming. Coming to the third topic, while loop and do while loop. Introduction to loops. Loops are essential constructs in programming that allowed for repeated execution of code. They help in automating repetitive tasks efficiently. Understanding loops is fundamental for writing effective algorithms. What is a loop? A while loop repeatedly executes a block of code as long as specified condition is true. This type of loop is evaluated before the execution of loop's body. If the condition is false at the start, the code is inside the loop will not execute at all. Syntax of while loop. The syntax typically includes the keyword while followed by a condition in parentheses. Curly braces are used to define the block of code that will execute if the condition is true. Example, while in the parentheses condition open flower bracket code to execute, then close the flower bracket. Illustrate this structure. Example of while loop. Consider a simple example where we print numbers from 1 to 5. The loop will continue to execute as long as the counter is less than or equal to 5. This demonstrates how the condition controls the loop's execution. Understanding infinite loops. An infinite loop occurs when the loop's conditions always evaluates to true. This can lead to a program that runs indefinitely, consuming resources. Properly managing loop conditions is crucial to avoid infinite loops. What is do while loop? A do while loop is similar to a while loop but differs in one key aspect. The code inside a do while loop is executed at least once regardless of the condition. This makes it useful when the code needs to run before the condition is tested. Syntax of do while loop. The syntax begins with the keyword do followed by the block of the code to execute. After the block, the condition is checked with while inside the parenthesis condition. Example: do a flower bracket code to execute while in the parenthesis use condition shows this the structure. Execution of do while loop. An example can illustrate reading user input until a valid entry is received. The code inside the loop will execute first, allow for initial input collection. This guarantees that the user is prompted at least once regardless of input validity. Key differences between while and do while. The primary differences lies in when the condition is evaluated before or after execution. While loops may not exist if the condition is false initially, unlike do while loops. This makes do while loops preferable in scenarios where at least one execution is necessary. Use cases for while loops. While loops are ideal for scenarios with an unknown number of iterations, such as reading for a file. They are commonly used in situations that require repeated execution based on dynamic input. This flexibility makes while loops a powerful tool in many programming languages. Use cases for do while loops. Do while loops are suitable for menu-driven programs where the menu must display at least once. They can be useful for validating user input with at least one prompt for the user. This ensures that the program behaves predictably even with initial user errors. Common errors with loops. A common error is neglecting to update loop variable leading to infinite loops. Another mistake is incorrectly placing conditions that may not allow the loop to terminate. Proper debugging techniques are essential for identifying and fixing these issues. Performance considerations. While and do while loops can impact performance based on their execution frequency. Optimizing the condition checks can enhance the loop's efficiency. Understanding the implications of each loop type can lead to better performance in applications. Best practices for loop usage. Always ensure that loop conditions will eventually evaluate to false to prevent infinite loops. Using meaningful variables names for loop counters to enhance code readability. Comment your code to clarify complex logic within loops, aiding future maintenance. Conclusion. While and do while loops are fundamental for control flow in programming. Each type serves different purposes and can greatly enhance code efficiency. Mastering these loops is crucial for any aspiring programmer to tackle complex problems effectively. Coming to the last point, pointers. Introduction to pointers. Pointers are variables that store memory addresses of other variables. They are crucial in a crucial role in dynamic memory allocation and data structures. Understanding pointers is essential for effective programming in languages like C and C++. What is pointer? A pointer is a variable that holds address of another variable. It allows the direct access and manipulation of many memory locations. The syntax for declaring a pointer includes an asterisk. Declaring pointers. To declare a pointer, use the data type followed by an asterisk and the pointer name. For example, int. PTR declares a pointer to an integer. Pointer initialization. Pointer can be initialized using the address of operator. For example, int var equals to 10, int PTR equals to and var initialization PTR to point to var. Differencing pointers. Pointers are differencing a pointer means accessing the value at the memory address it points to. This is done using the asterisk in front of the pointer variable. Pointer arithmetic. Pointer arithmetic allows incrementing or decrementing pointers to navigate memory. Adding one to the pointer moves it to the next memory location of its type. This is particularly useful when working with arrays as pointers can represent array elements. Pointers and arrays. In C, the name of the array acts as a pointer to its first element. For example, int ARR in the square brackets 5 can be accessed using ARR or and ARR in the flower bracket 0. This relationship allows for efficient array manipulation using pointer arithmetic. Function pointers. Function pointers allow you to store the address of functions in variables. This enables dynamic function calls and callback mechanisms. They are often used in implementing event-driven programming and the state machines. Dynamic memory allocation. Pointers are essential for dynamic memory allocations using functions like malloc and free. You can see this in the given figure. Pointers to pointers. A pointer to a pointer is a variable that stores the address of another pointer. This allows for the creation of multi-dimensional arrays and complex data structures. This structure involves using two asterisks as in the int PTR. Common pointers errors. Common errors with pointers include differencing null or uninitialized pointers. These errors can lead to segmentation faults and unpredictable behavior. Always check if a pointer is null before differencing its prevent crashes. Pointers and structures. Pointers can be used to access and manipulate structures efficiently. For example, struct student in the flower brackets int age can be accessed using a pointer. This enables dynamic data structure like linked lists and trees. Smart pointers. Smart pointers in C++ help manage memory automatically to prevent leaks. They include a unique PTR, shared PTR, and weak PTR, each serving different purposes. Using smart pointers simplifies memory management without manual allocation and deallocation. Conclusion: pointers are very powerful feature in programming that offer flexibility and efficiency. They acquire careful handling to avoid common pitfalls such as memory leaks. Mastering pointers is crucial for advanced programming techniques and data structures. Thank you.